So the second way that we can calculate the acceleration here is by using the gradient. And if you remember, the gradient from the distance time graphs is the rise divided by the run. Okay, and this is a little bit easier to manage when it comes to graphing instead of trying to track down the u's and v's. So what we do is we look at our graph just like the distance time graph, and we decide to ourselves by how much has it risen. So you can see that it started out at 0 and it's risen. The rise was 80, but don't forget the unit. Sorry, it's 8 not 80, 8 meters per second. Okay, and in that time has ticked along on the time axis. So we've got a run that spans from there all the way to here, and that's 10 seconds. So my run is 10 seconds. So very straightforward. The acceleration from the graph is the gradient or the slope. So it's the rise over the run. It has risen by, and that's a positive 8 meters per second because it's come up. Okay, so if you remember, we said the velocity can be a vector. So if it's positive, it comes up. If it's negative, it comes down. Okay, so we'll have a positive 8 meters per second for a rise divided by a run of 10 seconds. And we wind up with the exact same thing as we had before, 0.8 meters per second squared. So our acceleration is the exact same, 0.8 meters per second squared. Okay? So try those in the next examples.